The shelter object, the most complex structure ever built by mankind. It encloses the destroyed force power unit of the Chernobyl nuclear power plant. The conditions inside are comparable to those on another planet, and work there is extremely dangerous. So to help people who explore it, special robots were developed. But back in 1986 it all started with this, an upgraded toy tank. This is the ultimate story of the precise recreation of the very first successful Chernobyl robot, which in 1986 assisted the initial researchers of the Sarcophagus. Its story was believed to be half-mythical because, as it happened 37 years ago, this time was long enough for facts to fade away. So, before this board was filled with facts and connections between them, we needed to conduct an extensive research to eventually bring this piece of history back to life. That work had many unexpected turns, and about that you can find on our Patreon page, but for now we'll focus on core things. It all began with this very essential piece of text. These are the memories of Oleksandr Borovoi, a physicist of so-called complex expedition of the Kurchatov Nuclear Institute. The expedition served as the main research force for the destroyed Unit 4 during the first 5 years of post-Chernobyl history, and Mr. Borovoi was one of the scientific managers. And in his book My Chernobyl, he provides the only existent description of this tiny robot. The first successfully functioning robot that actually helped us in 1986 was a children's toy tank. It was made of plastic, about the size of a telephone, had tracks and a long cable leading to the control panel. The tank could move forward and backward, turn around and make noise simulating gunfire. Well, the last feature was not useful at the unit, but the others were fully utilized. So we replaced the cable with a longer multi-core one, added a dosimeter, camera, thermometer and a powerful light source. And now the tank conducted primitive radiation and thermal reconnaissance. It performed its task with honor and was relatively easy to decontaminate. The tank lasted until spring 1987, after which it was no longer subject to decontamination, so it was buried inside the unit. The toy tank was purchased for 14 Soviet rubles by one of Oleksandr Borovoi's colleagues right here in Kiev. Back in 1986, at this very place next to the central street was a huge shop for all kinds of toys for kids. In the paper version of his book there is this black and white image that confirms the robot's existence. Yet it was not sufficient for precisely identifying its design, so we began to check the scientific publications of the Institute of Nuclear Power Plant Safety. This institute is the successor of the Kurchatov expedition to which Mr. Borovoi belonged, and nowadays it brings together top-class experts on the sarcophagus and its robotics. So, after a long search, we discovered a color shot in one article, and later another one from a different angle. And this marked the beginning of intense analytical work. It is visible that here is some box with electronics, equipped with a powerful light, which is strapped to the chassis. This is presumably a camera lens, and this looks to us as a C8 or C14 radiation detector. On the back there is something that looks like a wire mesh and two connectors, one likely is RP15, another is SR50. Atop the box a few dosimeters are attached to understand the dose a human would receive if they were to go to the place where a robot operated. These dosimeters are clearly of a type ID1. They have a distinctive eyepiece, allowing the reading of the received dose. But most importantly, by them we obtained a hint regarding size proportions. Still, the question remained, which toy was used exactly? Shortly after, we received a hint from one of former engineers and were able to locate the original footage captured by the Kurchatov expedition back in 1986. You could probably see it in a few early documentaries as well. And it became clear that one essential detail was missing in our blurry pictures, those 5 features in the front. And this was the detail that brought the puzzle together. In the Soviet Union there was a variety of toys produced, although obtaining a good one mostly was a real challenge, so nowadays many of them are virtually forgotten. So we reached one of the top Ukrainian collectors of vintage toys, and in a couple of days the box of wonders arrived. So just look at this, and it seems that in his memories Oleksandr Borovoi recalled things somewhat incorrectly. It was not a tank, but an intercosmos planet rover. This toy was produced also here in Ukraine, in Kharkiv, specifically by the Electronmaster factory, which nowadays is known as Hartron. The Hartron specializes in space, satellite and military systems. For example, they designed the guidance system for the SS-19 ICBM. That said, they had all the means to produce high-quality toys as a byproduct, and I must say this one is really gorgeous. So when it moves, this antenna should rotate around, and those little control panels, front lights and red signals should glow, so actually should be pretty much fun. Well, our one unfortunately was stored improperly for quite a long time, so the lights are non-functional, but when we provided just a few volts of energy to it, it started to slowly move. But the true excitement came to us when we looked inside. Because its chassis appeared to be very durable and it has a large battery compartment which can be used for placing their detectors. But the greatest feature is the traction. The traction is based on two well-built mirrored gearboxes that act independently. Moreover, they can be easily replaced because they have a special coupling. So now, if you look here again, it's possible to understand that this colorful fragment was actually two gearboxes. But even more interesting it was with the camera. So upon the next inspection of the footage, we noticed this silver bezel. And all of a sudden we realized that it was not a box with electronics. It was the camera itself, but not a CCTV one as we initially expected, but one for home use. So it appeared to be a Russian-made Electronica N801 camera that you normally connect to a videotape recorder to get a black and white picture with sound. After some searching, we were able to find two cameras of such kind. One had an Industar lens with 50mm focus distance, and the second one had a Vega 20mm lens. And as you can see, it is a perfect match. The camera comes with a handle, a microphone and a viewfinder. Since none of these components are needed for our project, we decided to inspect its internals to figure out a way how to remove them safely. And even a quick examination of both cameras revealed a noticeable difference in quality between these consumer products and, for example, their professional sister KTP82, which is intended for CCTV systems. In Electronica camera, everything is mounted on two circuit boards with quite questionable capacitors. There are a lot of loose wires around the vidicon, but the PCBs are connected with short wires instead of any kind of connectors, which makes dismantling of that quite challenging. This metal tag indicates that all this was produced in 1981 and cost 840 Soviet rubles, which is equivalent to 5 to 9 monthly wages of Soviet citizens. In American dollars, it's approximately 1200. Now, knowing the size of the camera, we were able to identify the lights used on the robot, so it turned out that they used two reflectors from military flashlights, which normally would take 3R12 type batteries. But before installing them, we needed to make the most intact camera again functional, so I called our good friend Dmitro, also known as Electronmaster, who gladly agreed to help. And the camera went to Odessa. Honestly, I cannot even describe the amount of work he had to do. He checked signal oscillograms and voltages at all control points on PCBs, and there are many of them, changed most of the capacitors and many other parts. All of that required reconnecting those wires between those two PCBs many times, because you cannot access them in any other way. Eventually, the final problem was detected with this transformer, which, due to the low quality, had a breakage inside. And after he fixed that, the 42-year-old camera started to work like new. With the core elements identified, we could start to assemble the robot, but still we needed some more components. So we went to the cave electronics market, where it's possible to find a lot of electronic surplus. And given that we wanted to stay period correct as much as possible, this was their best place. So here we bought some connectors, buttons, power supply, as well as wires and signal cables for the control panel. And we will start with the installation of a radiation detector. So those dosimeters strapped to the top can provide information only about the accumulated dose, but not about the radiation level in a particular spot. There is no information about which device was used for this, but given that the electronics of the camera should stay functional, we guessed that they used a standard DP5V device with the highest readable level of 200 roentgens per hour. Since we are making a replica with no actual plans of using it in heavily contaminated places, we will wire the probe, but we will somewhat simplify it by removing the steel protection that normally filters out alpha and beta particles. We could of course compensate it with the lead foil of a specific thickness and shape, but for this task it is not needed. So inside the probe there are two Geiger tubes which are mounted on a long PCB. And this PCB perfectly matches the size of the battery compartment. So we decided to cut a part of the outer plastic enclosure, but left at the place the inner metal nut, which will allow to secure it in the chassis. Then we remove the contact parts of the battery compartment and unnecessary power wires, because the power will come now from the control panel. And finally, we remove the pieces of plastic that held the batteries together. So that's what we got. Next step was to install connectors. So we will use 23-pin RP15 connector for command and detector signals and all power lines. And also we will place a round 10-pin connector, matching the one on the camera. If you look at the original robot, you will notice that the camera is strapped, not hard-mounted, which means it was removable either for decontamination or repair purposes. So this round connector will act as a bypass one. The plastic of the chassis is still pretty strong in most places, but the toy was made in 1980, so it became already quite fragile when you cut it. So we used a soldering iron to melt it in a proximate shape of the openings we needed for connectors, and then applied some gentle finishing touches with a sharp knife. And the connectors will fit there just perfectly. Next, we made a quick wiring diagram, and next step was to secure our radiation detector. Well, what is great, that all the wires from it perfectly passed through the existing opening in front. All in all there are 5 of them, and they all are numbered. The design of the chassis allows to conveniently arrange all the wires around the former battery compartment. For now it was needed, however, just to understand the optimal length. At the market we also got this electronic temperature sensor. Given that this round part is just a wire box, we decided to cut it away, solder their 2 wires and drilled a hole for them. And this way it perfectly fits like this, and what is really neat, it can be secured using the original opening for a screw on a chassis. Now it is the time to solder the signal connector, so as I told it had 23 pins and we will use just 16 of them. So once it is ready, we added a bypass connector. 2 wires in it are power lines of the camera and 2 more are for the front lights. Well, that starts to look a bit complex. The next step was to install and secure connectors on their place, and the round one will hold only on 2 screws, but it looks pretty sufficient. Now it is the time to think about the camera mount. Well, it is noticeable that the camera aligned not parallel to the chassis. Instead, it's a bit tilted up, likely to get a more effective view angle for it. So it is mounted on a sort of metal corners, secured by L-shaped mounts on the back and a metal stripe on the front. So for horizontal mounts and front clips we will use aluminium, and from the white stripe we will try to make a mount for lights. So first we installed these 2 L-shaped mounts, and what is quite beautiful, we secured them just in the original openings, and that will perfectly match the dimensions of the camera. We cut 2 more parts, drilled some openings and placed them mirrored on each side. As for the front part, initial idea was to make one shaped part, because it would ensure that the camera mounts are parallel. But when we made it, it appeared it was not possible to actually install, because the tracks were obstacles, so instead we cut them to parts. Probably it was done like this in original robot, and drilled a few openings in the bottom, and this is what we got. Now it is a time to prepare the camera and mount the lights, and we need to remove this handle, which is secured inside with the hidden bolt. Then we do not need this microphone, but there is an opening behind it, so instead there will be placed one light and another one will be here instead of viewfinder. Unfortunately, bending them out for lamps from aluminium didn't work well in a home conditions, so instead we decided to use some plastic, and this is what we made. So this is our camera assembly. Time to install. And just look at that. You know, it starts to look as a long forgotten prototype. It is still much to do, but to be honest, it feels really incredible, you know, just to see how the piece of history is slowly reappearing from forgotten times. And then came a challenging task of making the signal cables. The thing is, look how flexible is that cable. So we found with certain effort a Soviet flexible coaxial line, but also we need 15 wires for signals and power. The problem, there were no Soviet cable available for some meaningful money, so instead we picked a modern one, but it appeared to be too thick. So we decided to remove its outer insulation and assemble together with the coaxial inside the flexible tube. Well, frankly speaking, it was a really complex manipulation, so we managed to make just 3 meters long cable. But as you can see, the result is super flexible, and don't forget that the coaxial cable is also inside. In addition, we secured the tube on the connector in the original technique, using a thick rolled thread soaked with special varnish. So that's what we got. And now it is a time to make a control panel. Well, there is no information remained about how it looked like, so we decided to go just by logic. The base will be this metal case, which had enough space for all internals. There are also 2 connectors, but they have too few pins, so we will need to change them for bigger ones. But first we needed to cut the necessary openings. And eventually we assembled this. It can be stationary or held in hands. There are 3 control switches equipped with indicators for camera, lights and motion. And the motion is controlled using these 4 buttons by switching the polarity of motors. This is the meter for our thermometer. Well, we unfortunately could not find with a smaller scale, so for now we have this. And below is embedded the P5V dosimeter handset. And now it is the time to try our robot in action. Okay, camera on, lights on, motion control on. And now let's try to move it. Well, of course, on a flat surface it works just perfect. But now let's try on a more complex terrain. Well, unfortunately we don't have a bucket of radioactive rubble, so instead I will use a lot of electronic components. Well, while this choice looks somewhat funny, in fact it's a very nasty sticky obstacle that can get into the mechanisms, pretty the same as inside the shelter. So let's try. So as you can see, it has some notable troubles in some places, though not the last reason to my mind is that its tracks, which made from rubber, are a bit solidified over the years of being in storage. And also, I guess that back in 1986, the engineers actually provided some higher voltage to motors to gain more power, because the robot became heavier. We, however, used the standard one. But as you can see, it successfully got out of this makeshift trap. As for the camera, frankly, it works so-so. The image is not very sharp and it has distortions. And that what looks like the standard test table from this camera. I think, however, the problem is exclusively in the coaxial cable, so I will change it in the next few days. But, no matter that, it feels really incredible just to see it on this table after so many years of being forgotten, and especially when you imagine this little thing was crawling there inside the damaged Unit 4 doing its job. Maybe only on a basic terrain, but it did it, and eventually it remained there forever. So technically, when you're watching this, exactly the same little robot is laying somewhere inside the sarcophagus, to be never touched again. Well, our robot's gonna have much better future, and actually a few days ago we made a presentation of this project in the National Museum of Chernobyl, which is located here in Kiev. We have, by the way, a video about it, and we had many guests and also a few speakers from the Institute of the Nuclear Power Plant Safety Problems, and actually our future plans is to place it on exhibit in a museum, but not as some static thing in a glass box. We are actually thinking to make a simulation of a terrain, so if you appear here in Kiev in the museum, you'll be able to try to actually drive it. I'm also going to fix this coaxial cable, so the image would be much better. And that's it for today. If you want to see the backstage of our work, also research details and so on, come to our Patreon page, because there we have, I think, 9 previous updates about this project. And I hope you like it, so stay tuned for more next time.